All right, today we are going to go through Avogadro's principle, which is the stoichiometry of gases. So Avogadro's principle states that at STP, which let's talk about what STP is. STP stands for standard temperature and pressure. And what standard temperature and pressure is? Standard temperature is 0 degrees Celsius, also known as 273 Kelvin. Remember, we talked about Kelvin at the start of the school year. And standard pressure is 1 atm. ATM stands for atmospheric pressure. When we get into more units about gases, we'll learn about how temperature and pressure changes. But Avogadro's principle states that as long as we are constantly at standard temperature and pressure, 1 mole of any gas is equal to 22.4 liters. So assuming STP, standard temperature and pressure, you know that you can now convert 1 mole of any gas, it must be a gas, to volume. This is a volume when we're talking about liters, using 1 mole to 22.4 liters. So let's see what that looks like in terms of a problem. So calculate the volume that 0.881 moles of a gas at STP will occupy. So notice this is the same constant no matter what that gas is. So even if I don't give you helium gas, oxygen gas, something like that, as long as you have a gas and it's at STP, you can convert it. So your given here is 0.881 moles of gas, and your unknown is calculate the volume. And volume we solve in liters, so liters of gas. You don't need a mole ratio, you just need that you are going to go from moles of gas to liters of gas. And to do that, you'll use 1 mole equals 22.4 liters. So let's get started. 0.881 moles of gas is what we start with. And we are immediately going to drop that down to the bottom. Moles of gas on the bottom, and we're going to go to volume. So liters of gas on the top is what we are looking for. We just said 1 mole of gas equals 22.4 liters. So now, if we want to go through, we've crossed out moles of gas. We are left in the unit we are looking for. So in my calculator, remember, multiply by the top, divide by the bottom. So I would just do 0.881 times 22.4. You can divide by 1, but that's not going to change it at all. And you should get 19.8688. However, number we start with has 3 sig figs, 881. So our answer needs 1, 2, 3 sig figs. So we're going to chop that off. This is going to round up. So we will walk away with 19.9 liters of gas. Let's do one more together. So this time we are asking a concept question. So you have 3 tanks of gas: nitrogen gas, oxygen gas, and helium gas. And we are all at STP. If all 3 tanks are the exact same size in volume, which tank has the most molecules? Well, how would we figure this out? Let's start with nitrogen. Let's say that that volume is 1 liter. If we have 1 liter of nitrogen gas, we can convert that to figure out how many molecules we have. We can first go from liters of nitrogen gas to moles of nitrogen gas, knowing that 1 mole equals 22.4 liters, since we're at standard temperature and pressure. Then from moles, we can go to molecules by doing 1 mole of N2 gas on the bottom, and our favorite 6.022 times 10 to the 23rd, N2 molecules on the top. Now, we can solve for this, but let's just think about this. if we also have just 1 liter of oxygen gas and 1 liter of helium gas, there was no point here where we dealt with grams, meaning we never had to deal with the molar mass. No matter what these are, we're going to go from liters of gas to moles of gas, and that's 22.4 to 1. Then we're going to go from moles of O2 gas to molecules. No matter what, we're taking 1 divided by 22.4 times 6.022. 1 divided times. Helium's going to be the same. If you don't believe me, write it out and solve all of these. These should all equal the same number of molecules, regardless of what gas it is, because we're using 2 constants that work for any gas. What I want you to do on your own is example number 16. Please pause this and try it on your own. I'm going to do it on here, but I'd like you to try it on your own and then come back and check your answer. So pause your video now, pause your video now, pause your video now. All right, hopefully you actually paused your video, completed number 16, and now you're back to check your answer. If that's true, let's go through this together. Did you write that your given was 0.221 grams of oxygen gas? And did you write that your unknown is liters of oxygen gas? Hopefully you took a route that went like this. I would start with grams of O2 gas. From grams, I could go to moles of O2 gas, and from moles, I can go to liters of O2 gas. If you didn't actually pause and do this on your own, now that you have a route, please pause this and do this on your own before you come back. Okay, time to rock and roll. 0.221 grams of O2. Then we're going to drop that straight to the bottom, grams of O2 on the bottom, moles of O2 on the top. And that is 1 mole to our molar mass of O2 is 32.00. If you don't know how to get that, ask someone or look at your periodic table. Then we'll drop moles of O2 on the bottom and put liters of O2 on the top. And we now have a constant 1 to 22.4. If you solve this out, you should get 0.155 liters of O2.